Hello everyone, we're looking at Investigation 3, the first page of Investigation 3. I'm actually going to make a video for each of the pages for Investigation 3, or a couple of them to start with. You need to make sure you're doing the work within your table of values well, as well as making sure that you're plotting your points well. Alright, so we start with our usual, we've got y equals sine x, all the information that we have on here. Hopefully you're getting used to the pattern that exists with y equals sine x. In other words, that you're starting to become familiar. It goes through the origin at pi over 2, it's at 1. Then it goes through the x-axis at pi, and down to -1 at 3 pi over 2. Back up to 0 at 2 pi, and then back the other way. The same sort of pattern. Okay, I put an arrow on the end there because my domain is not restricted. Okay, and over here we go down to -1, and then 0, 1, 0, back that way, 0, 1, 0, and this is the wave. And the submissions that have already come in are looking really good. Whew, almost tripped there, sorry. Are looking good with regards to making them look like waves and not peaks and valleys. You don't want points on there, they're waves. Okay, now let's look at y equals sine of, in brackets, x minus pi over 2. Now think about what kind of transformation is actually happening here. If you did the video on transformational form of a sine function, you'll notice that this is in the horizontal translation position. Okay, so what should be happening here is that our graph, this graph, is moving, everything is moving pi over 2 units to the right. Okay, horizontal translation, pi over 2 units to the right. That's what should be happening with regards to that. Just looking at the equation. So let's go down, pop down here to 0 and look at what this algebra would look like. Y equals the sine of, substitute 0 in for x, 0 subtract pi over 2. So that equals the sine of negative pi over 2, which we then need to find on our unit circle. And I forgot to draw one here. Just pop it in here real quick. 1, 0, -1, 0, up here, 0, 1, down here, 0, -1. Okay, all right. So sine of negative pi over 2 is -1. All right, so -1 goes here. Notice over here it was 0, 0. Here it's 0, -1. Let's pop that on here. 0, -1. There we go. Okay. Next one, do the algebra again. Pi over 2. Okay, so substitute pi over 2 in for x. Pi over 2 subtract pi over 2 is the sine of 0. Sine of 0 is 0. So this becomes 0. So pi over 2, 0. Okay, and you'll notice that we're starting to develop our pattern here. There shouldn't be any other transformations, right? There's no other transformations listed here, so that means the amplitude should stay the same, the period should remain the same. Okay, let's see, pi. So y equals the sine of, substitute pi in for x, so that equals sine of pi over 2. Sine of pi over 2 is 1. Okay, so that becomes 1. And as you continue this, we will see what's happening. Let's talk about this horizontal transformation, pi over 2 units to the right. In other words, this point from y equals sine x has moved pi over 2 units to here. Okay, so on my graph that's 2 grid marks. On your graph it's also 2 grid marks, the graph that's given to you there. Okay, so that's moved over there. Notice this point here from y equals sine x has moved that same distance over to here. this point here has moved that same distance. So this has actually happened. We've been moving to the right by pi over 2 units. So complete that table, working through the algebra with it, and your graph will continue to keep moving over that point. This point moves over here, this point moves over here, this one moves over to here, this point moves to here, this point moves to here, okay? And then that pattern will continue, so you can continue the pattern all the way across your grid given to you. Okay, so here this pattern would continue and come down here and then go up. Now, when you're putting your arrows on, make sure extend beyond the point that's given and in the direction that you need to go, okay? I don't want to see any graphs like this, okay, because that's not what that graph looks like. It needs to continue in that same pattern, so it needs to come down to that point and then pop back up and have an arrow on it. All right, so maximum. Has the maximum changed here? No, maximum is still at 1. That's as high as the graph goes. The minimum is still at -1. The period also has not changed, okay? That period is still the same. Period of y equals sine x, the black graph, starting here, start to repeat itself here, okay? But if we take a similar place, well, we could start here at the y-axis still if we wanted to. When does it start repeating itself? Right here. So yes, it's still 2 pi. Or you could take from here around to here, and then it's repeating itself. Excuse me, that's 5 pi over 2, subtract pi over 2, which is 2 pi still. All right, so period remains the same, 2 pi. Amplitude. Amplitude also remains the same. Amplitude is from the principal axis up to the maximum, or from the principal axis to the minimum. Stays the same, it's still 1. And the principal axis is still right there in the middle of the graph, which is our y equals x. Okay? All right. I will see you in the next video for the next page.